Hello students, welcome back to the sixth video of this playlist. So in this video we will be solving question number 6 from May 2024 P1 paper. So let's see question number 6, like what's the topic of question number 6. So basically the concepts behind question number 6, it's from it has been discussed in chapter number 3 of your P1 textbook, that is equations and inequalities. So in order to be able to solve this question, definitely you should have practiced questions, and definitely you should have known the concepts from both chapter number 2, that is quadratics, as well as equations and inequalities, that is chapter number 3. Okay, so let's get started with question number 6. So right at first you can see a figure, that is figure number 3. It's and the sketch on that figure, two equations, sketch of two equations. One is a curve and another one is a straight line. So the curve C, it's a quadratic curve, and line L, it's a straight line. So that the equations are given. The line with equation y minus 5x equals to 75. Its equation is given. The equation of line L. The curve C, the equation of curve C, it's also given as y equals 2x squared plus x minus 21. So this is the equation of the curve C. Okay. So the line L intersects the curve C. The line L intersects the curve C at the points P and Q. Okay, let's see point P and Q here. It is intersecting at point P and point Q. Okay, the line L intersects the curve C at point P and Q. Okay, as shown in the figure, we could see in the figure. Find, so part A asks to find using algebra the coordinates of P and the coordinates of what? Q. Okay, so point P and Q are basically the points of intersection between the curve C and the line L. So at points P and Q, we know that since it is the common point between the line L and the curve C, so their x and y values would be same, right? What I meant here is that the x and y value for this equation would be equal to the x and y value for that equation at point P and Q. So that means their y values are equal. So what we can do here is that we can equate the two y values are equal, right? So we can equate the two y's, right? At points what? P and Q. At points P and Q, we can equate what? The equation of line L, it's 75 plus 5x. Okay, and the equation of curve C, that is twice of x squared plus x minus 21. Okay, so their two y values are equal. Okay, so what we can do now is that we can take all of the terms on the same side. So take the terms on the left side to the left hand side to the right hand side. So we'll get twice of x squared plus x minus 5x, that means negative 4x, minus 21 minus 75, that means this is negative 96, that is equals 0. Okay, now divide both sides by 2, so we'll get x squared negative twice of x, negative 48, that is equals to what? 0. Now let's solve for x. If you solve for x, you have to solve this quadratic equation. X squared negative twice of x minus 48, that is 6 times 8, right? So we can write x minus 6. We can middle term it using x minus 6. Okay, x plus 6 times x minus 8. Okay, equals to 0. I just middle term like factorized the quadratic equation using middle term factorization. So what you will get here, either x equals to 6, okay, either x equals to negative 6 or x equals to 8. So we got the two possible values for what? X. So if you see the figure, you can see that point P lies on the negative x-axis. So here x equals to negative 6. And point Q lies on the positive x-axis, so that means here x equals to 8. So we got the x coordinate of the 2 points. Okay, so what we can write here, that at P, what we can write, x equals -6. Now you can put this x coordinate into any of the equation. So since line L, it's a linear equation, so let's put it there. So you get y equals to what? So you will get y equals to 75. It would be 75 plus 5x, right? So 75 plus 5x, that means 75 minus 30, right? 5 times -6, that is -30. So 75 minus 30, that would be what? 45, right? That would be 45. So we got the coordinates of point P, that is -6 and 45. Okay, next is at Q. What would be the coordinates of point Q? At Q, x equals to what? 8, since it lies on the positive x-axis. So y equals to what? 75 plus 5x, isn't it? 75 plus 5x, the equation of line L, right? 75 plus 5x. So 5 times 8, that is basically 40. So 75 plus 40 would give you how much? 115. So coordinates of point Q is basically 8 and 115. So these are the coordinates of point P and point Q. Okay, let's see part B from question number 6. So in part B, they are asking that the region R shown shaded in figure 3 is bounded by C, L and the what? X-axis. So let's see in figure 3, the region R. You can see that the region R, it's bounded by line L, right? And the curve C and the X-axis, right? So the question asks in part B that using inequalities, we need to define what? Using inequalities, we need to define the region what? R. Using inequalities, we need to define the region R. Okay, so we need to use the concepts of inequalities, right? And we need to define the region R. So for this question, let's consider the position of region R. At first, consider the position of region R with respect to the line L. Okay, you can see that the region R is just below the line L. That means at the region R, the values of y would be less than the y values of line L, right? So what's the y values of line L? Basically, it is given by the equation what? Y equals to 5x plus 75. That means with respect to line L, the position of region R is what? Less than or equal, since it is a solid line, right? Since it is a solid line, that means the y values of the line L is also included in the region R. So for part B, at first what we got? Y is what? Less than or equal 5x plus what? 75. So this is the first one we got. Next, they said it's bounded by the curve C line L. So we already considered line L. Now let's consider curve C. With respect to curve C, the position of the region R is also below the curve C. So since it's below the curve C, so same case as line L, at region R, the y values would be less than the y values of curve C. So equation the y values of curve C, it's given by what? 2x square plus x minus 21, right? So at region R, y values would be less than or equal the y values of curve C. Okay, 2x square plus x and then minus 21. Okay, that's minus 21. Done. We have considered the position of region R with respect to curve C. Next is with respect to the x-axis. It's pretty easy to say. It's just above the x-axis. That means here the y values would be what? Y values of region R would be greater than or equal what? 0. Because it's above the x-axis, that's why, where y values would be positive. Now, for 3 marks, most of the students will do a mistake here. They will consider that if I give these 3 inequalities, then I'm done with 3 marks for like 3 marks for the 3 inequalities. But it's not working like that. Look, if you consider the 3 inequalities, we said what? Region like R is just below the line L. This is this part, right? And then we said the region R is below the curve C. This is which part? This part, right? This whole part, right? So below L, below curve C, and above the x-axis, this is what? This part, right? Region R, and also it consists of this part. The 3 inequalities that we have just written in our answer to part B, this is basically considers this part and also this part. But is this 2 parts the region R? No. The region R is between this x coordinate and that x coordinate. Or you can ignore this x coordinate because what it is in this way, it's getting what? Below the x-axis. So you can ignore this part. It should be considered that the x values should be, the x values at region R should be what? Less than this x value. So this x value is what? This x value is the x value where the curve C is intersecting the x-axis. Make sense? Because if you don't consider that, then this part is also getting what? With our region R. Okay, so to remove this part, we have to limit it x less than or equal that x coordinate. So let's figure it out, the x coordinate of that point. So this is the points of intersection. It should be done in rough, so the workings not need to be shown. Equals to 0. So if you solve it, you will get 2x squared plus what? 7x minus 6x minus 21 equals to 0. It's just a rough work. So twice of x times x plus what? You can take x common just from here. You take x common, you will get what? You will get twice of x minus 7, and from here you can take negative 3 as common, right? Negative 3 as common, you will get twice of x minus 7 equals to what? 0. Plus 7, sorry. It would be plus 7. Yeah. So either x equals to 3 or x equals to what? Negative 7 over 2. So which one is negative value? Negative 7 over 2. That means here x equals to what? Negative 7 over 2. This is just solving it, like it's a rough work. You don't need to show it in the answer paper. You just need the x coordinate of the point where the curve C is intersecting the what? X-axis. So x is less than or equal negative 7 over 2. So we will write this in our answer part B, that is x should be less than or equal negative 7 over 2. And these are the 4 inequalities to define the region R perfectly. That's it. So that's all about question number 6 from May 2024 P1 paper.